Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. I'm Dr. Sandy Atkins, Sandy, and this is the last of our August series on the key models your children may be using this year to help them understand the mathematics that they're learning. Now, again, thank you to those who are newly subscribed to the channel. I really appreciate it. I hope others of you may decide to subscribe also. It's free at this point. And we're going to be looking at these key models, as I said. In this video, we'll look at pattern blocks, attribute blocks, and fraction kits, and let you see a few of the things that you may see your children using these for, and then some things to consider as you're helping your children. So let's get started, and I'm actually going to start us out by looking at attribute blocks. And these are just some of the attribute blocks. And as you see, as you look at these, there are some thick versions and some thin versions. Now, one thing that I've learned over my career is that preventing misconceptions from occurring is preferable to doing intervention at a later time, or getting in a situation that as your children progress up through the grades, we're going to have to unteach them something and then reteach it. It's easier to build that solid foundation from the beginning. And the reason I'm saying this may just be a stickler for detail, I guess, but I want you to notice there's a thick and a thin rectangular shape, and a thick and a thin triangular shape, and a thick and a thin circular shape. The concern or the consideration is that rectangles, triangles, and circles are names of two-dimensional shapes. That means they can have no thickness. And we get ourselves into a bit of a sticky wicket here by talking about thin circles and thick circles, because there's no such thing. Circles have no thickness. So these are cylinders. They have thickness, these cylinders. You can have a thin and thick cylinder because a 3D shape has a dimension of thickness. You can have a thin and thick triangular prism. These are all prisms, but I can't have a thin and thick triangle. So that's something we want to make sure that we're mindful of and help your children understand, is that even though this is a rectangular shape, it is not a rectangle. That name is reserved for two-dimensional shapes. So your children may be using some attribute blocks to start to look at dimensions of thin and thick. And that's an important thing for your young children to think about. But they may also be using them, again, you want to think about what makes something a 3D shape and what makes something a 2D shape. Now, these are pattern blocks. And I actually don't have all of the pattern blocks here. The pattern blocks also include a square shape, an orange square shape, and they include a longer, narrower parallelogram shape, rhombus shape, okay? So as we're looking at that, see, these pattern block shapes, we sometimes have the same issue. They'll get called a hexagon, a rhombus, or a parallelogram, a trapezoid, a triangle. Those are all 2D shape names. And if you notice, these are all at least 1/4 of an inch thick. So we want to be mindful of that. These are all prisms. So helping your child know that we might talk about the shape of the prism, a hexagonal shape, or this trapezoid shape, but it isn't the footprint is the actual trapezoid. If I put this into some type of Play-Doh or paint or something, I look at the footprint. Now, what this is helpful for, and what you may see this used for, is I can start to look at part total relationships. So if you notice, the two trapezoids will make trapezoid shapes. I got to watch myself, don't I? Will make the hexagon. These 3 blue shapes will also make the hexagon. So I could name these. If this is my whole, this is a half, this is a third, and you can see how many of these green pieces are you going to need? See, we're going to need 6 of them. So one of them would be called a 6. Now, we change it, and sometimes you'll see this happening. They might start out with telling your children that this is my whole, so name the other pieces, 1/2, 1/3, 1/6. I could start out by saying, well, this is my whole. What are the other pieces called? Well, this would be 2, right? This would be the green shape, the triangular prism would be 1/3. Okay, so this is 1/3 if this is my whole. And then what is this one going to be? 2/3. So we mix it up and then add some challenge for your children. I could do the same thing. If this is my whole, what's this called? 3. What's this called? 1.5. I put that on there nicer. What's this one called? 1/2. So you'll see pattern blocks used for a variety of things. Pattern blocks tessellate. I can actually fill the plane with them. And they can look at angle measures. What happens here? 360 degrees. So name the measures of these different angles. Okay. What do I find out? Are they all actually the same measure here? Would each of these be 120? And I can lay them on top of each other to see that angle measure hasn't changed with the shape. 3 come together, they're all the same size angle. Each of these would be 120 degrees. So we use them to tessellate, to look at angle measures, or to do as I just showed you, I can look at fractions with the pattern blocks. So many different things. Again, we just want to be careful about leading your child to think this is a triangle when it's that thick. Okay, so that's just that precaution. Now, the last thing I'd like us to look at are fraction kits. And you may see a bunch of rectangular pieces appear in the room one day if you help in the classroom. And you'll see all these different shapes, and your teachers may have them making this kit. And what tends to happen is they'll pick a color that is the whole and they'll set it aside. And they'll have another one and they'll have them fold it into 2 equal pieces. Okay. Now, one of the things I've learned is it's important for your children to kind of have that struggle with making the fractional whole. So if you notice what I said, fold it into 2 equal pieces, and they use the whole strip. And it may take them a couple of tries. And so for that reason, sometimes you may see the pre-activity is something with Play-Doh where they make essentially like a strip or a snake or a long piece with the Play-Doh, and then they have to just practice cutting it in 2 equal pieces. Okay, so they practice that. Sometimes they want to cut it in 4 equal pieces. And I know with Play-Doh, we tend to want to move it and cut it this way. But when I'm actually making the fraction kit, I'm taking this piece and cutting it in half. And I'm taking this piece and cutting it in half. And I hope you've seen with these videos, we aren't using these materials just to use them. We try to be very purposeful in how we use them, very mindful of the mathematics that's being learned with these. So I might go from a whole to 2 equal pieces to 4 equal pieces, right? And then to 8 equal pieces. So for me, I might do it in that order because it's a doubling and halving, right? If I can fold it into 4 equal pieces, then folding into 8 equal pieces is easy enough because I just take each of these and cut it in half, okay? And then we might do 3 equal pieces. And once I do 3 equal pieces, then it's easy enough to get 6 equal pieces. because it's half of these. Now, I'd like you to notice a few things here. For me, in my career, I found that making the kit tends to have a lot of power for your children over having pre-made kits for them. Um, there's a lot more learned in trying to fold a strip or a rectangular sheet of paper, a larger rectangular sheet of paper, into 2 equal pieces, or 4 or 6. And the struggle with that is it will hold them more than cutting out pre-marked strips. So that's why you might see this, and it might take more than a day because the children will get the hang of this at different rates. And your children, I know what happens sometimes is they'll cut a strip and it'll be crooked, and then they want to trim and trim and trim until it's perfect. And after a while, their pieces no longer equal that whole. So I have them check with each other and do that. The other thing I hope you notice is that I haven't labeled my strips, and that's very purposeful. Once the strips are labeled, then all your child has to do is read the label to know this is called 1/2 or this is called 1/4. You see, once I label it, or if I give them a commercial piece that's labeled, it's a reading activity. And what I need them to know is, why is this called 1/2? Or why is this one called 1/4 or 1/3 or 1/8 or 1/6? See, I need them to go back to the idea that since 4 pieces make the whole, one of the pieces is called 1/4. See, there's embedded practice when I don't label. So if your children come home with a fraction kit and they're working with the pieces and you want to try to help them and you go to label them, pause and think about, why may they be unlabeled? That could be very purposeful. And then the question to ask your children, well, how would you know what label to use here? See, that's what we want to keep revisiting with your children. So it may be that they start with folding paper. I sometimes start with cutting up Play-Doh snakes and getting used to the cutting before we go to paper, since this is forgiving. Sometimes we make this into a flat pancake and we do impressions in it and cut things into pieces. Okay, so you may see other pre-activities that are done very purposefully to help your children when they get to something like this. And then you may see extra holes in their kit sometimes, because when they get to mixed numbers, like 2.5, it's helpful to have more than one hole. It's helpful for them to see, well, I could make 2.5 with the 2 yellow pieces and 1 green piece. But I could also make 2.5 with the 2 yellow pieces and 2 orange pieces. Or I could make 2.5 with 2 of the yellow pieces and 3 of these pink pieces, because that would be 3, 6. See, we start to look at equivalency. We're using that, but we're beginning by having your children construct fractional units using fraction kits. And as I use long strips, because I tend to link mine to rulers for later, because your children may also cut into 12 equal pieces, right? They can take each of these and eventually cut those into 2 equal pieces. We might start with pattern block explorations and having them look at that. They might see stickers of pattern blocks. You might see other models. I cut them out of foam sometimes. So you might see versions of this, but we get a lot of mileage out of that, whether it's a geometry look, an angle look, or a fraction look. And then you may see these attribute blocks with your children. But again, keep in mind that idea of 2 dimensions, no thickness, versus 3 dimensions, thickness. What are the 2D shape names? So we don't want to give them an attribute of thickness, like thin and thick. And what are the 3D shape names? Cylinder over circle. Okay. I hope that helps. I hope that makes sense. Again, this will be the last in the August series on the key models your children may be using this year in school to help them understand the mathematics they're doing. If there's another model that you're interested in or you see your children using, please put a comment below and ask to see some information on that manipulative material, and I'll try to help you with that. So please leave those comments. Again, if you found this helpful, please give it a thumbs up, share it with others, consider subscribing, turn on that notifications bell so you know when other videos come out. I try to have them out on Tuesday afternoons. So I will continue with that. If there again, whether it's manipulative materials, these key models, or some other idea in math that your child is learning and you're wondering about, leave it in the comments and I'll check those out. Also, check out the description below for links to the key models playlist and other playlists with videos that you may find helpful this year. Thanks so much for watching, and I hope to see you in future videos.